Welcome again. I'm Bob Young, Assistant Professor of Mathematics at Bavard Community College. This continuing series of lessons is entitled Empowering Introductory Algebra. The series was created and has in mind students who have struggled with algebra in the past and for you returning students in need of a basic skills algebra review before tackling those college-level courses. Today, with the continued help of my awesome support staff of WBCC, we will bring you both lessons to build a strong algebraic foundation and study tips to improve your math scores all around. First, let's begin with some study tips. Going to the graphics, study tip number 1 is get organized. A lot of students I have seen in my career who have struggled with math as a subject are never organized. They have papers everywhere, stuffed in their textbooks, on the back of napkins, you name it. Create a math folder and keep it organized from topics to topics. I have students come in my office and bring their textbook and they say, Mr. Young, I need help on page 27, problem 15. And I say, sure, go ahead and pull that out and we'll look at it. And here's what I see sometimes. I see a book like this, pretty book cover notice, and they go to look for that problem, and I mean, they have got papers just stuffed everywhere. They're going, I'll get it right here in a second, Mr. Young, and they'll go through and look and look and look, and you know, they just have no topic-to-topic understanding or organization, and that hurts their overall performance in math, because studying math is unlike studying other subjects. And then they'll say, oh, I've got it, Mr. Young. Let me go ahead and get that out of my math notebook. It's not in my book here. So they pull out their math notebook, and it's almost as bad. They've got their math notes, but when they go to look for something, they're in here like, okay, let me find this. And no, it's still not here, Mr. Young. And at this point, you know, that's when I start talking to them about being organized. You know, and I say, here's how a math notebook should look. So going to my notepad over here, I look at this notebook and say, now here's what a notebook should look like. And if you've been following along with our series, Empowering Algebra, you could have a nice organized notebook, and you could have on the side here things you can take out. And if you followed along our first tape, you would have all of these notes, translating and evaluating algebraic expressions. And you would have all of these notes organized neatly in your math notebook. And this isn't even including the examples I did in that first series, that first tape. So you would have all of this. Now, when it comes down to it, though, when you go to an instructor for help, here's what you want to look at. I mean, students sometimes say, Mr. Young, I followed you in class, but I don't really understand once I get home how to do things. I mean, I did great. I followed everything you did in class, but when I got home, it just didn't make sense. Now, going back to my notebook here, here's what I ask them. Once they get the problems and notes and examples, have you done this? Have you worked problems on your own? Effort made. This is time well spent. It's hustle if you're in that coaching breed. Desire to succeed, motivation. This is what instructors cannot provide you. This is where you have to spend the time. Once we go through, we give you the good notes and examples and show you how you've got to do this part. This is what's going to get it done for you. Okay, so let me go ahead back to the graphics and run through the other study tips. So number 1, get organized. 2, also review notes and examples the day they were given. This will reinforce each concept and solidify it in your mind. Study tip number 3, and this is the one I mentioned earlier, practice enough outside of class. For each hour in class, you need to practice at least 2 to 3 hours outside of class to become proficient. A good coach in sports will tell their players that you play in games like you practice. In math, your test grades will reflect the amount of effort asserted by you, the student. And the 4th and final study tip, attend class regularly. If you miss class, be sure to get the notes and examples from your instructors or classmates. Excessive absence in math equals excessive gaps in one's knowledge. Remember, math builds from topic to topic. If you miss out, you can easily be left behind. All right, so we're going to gear it up today, and we're going to go to the graphics again, and we're going to begin today with addition and subtraction of real numbers. So when we add or subtract any two real numbers, same signs, we're going to look at the same signs first, check the visible signs directly in front of the numbers. And for that, add the two numbers and put the sign of the two numbers in your answer. Let's go to some examples of that. So for example, if we take negative 12 and we add negative 15, notice that the addition sign is separated from the negative number here. See, so parentheses in this case, we talked about this in the first tape. That means, hey, you're not multiplying, you're adding. So again, add the numbers, put the sign of the number in your answer. So 12 plus 15 would be 27, and put that sign negative in your answer. It's like if you go to the bank, if you take out $12 on Monday and $15 on Tuesday, you've withdrawn a total of $27. Okay? And it works even if you have more than two numbers. So if you have negative 8 plus negative 10 plus negative 7, simply add the numbers together. 8 and 7 is 15 plus 10 is 25. That would be a total of a negative 25. Fractions, you ask? I know my students just love fractions. Now, in order to add fractions, your basic skills tell you you need a what? Yes, a common denominator. So what you want to do here is go ahead and get that common denominator, in this case of 21, multiplying the denominators together. Changing 2/3 into 21, you have to multiply the 3 by 7, and whatever you do to the bottom of a fraction, remember you must do to the top. So this will give us 2/3 is 14 over 21, plus 1/7. To get 1/7 into 21, a common denominator, we multiply both top and bottom by 3, and that gives us plus 3 over 21. So now that we have the common denominator, we can add the two numbers and get a total of 17 over 21. And the same works for negative fractions as well. If the signs are the same, we're going to add those two numbers together, put that sign in the answer. So for this example, we've got negative 1/2 plus negative 3/4. We're going to need a common denominator of 4. So negative 1/2, multiplying both top and bottom by 2 to get to that common denominator of 4 would be a negative 2/4, which if you think about it reduces to the negative 1/2, so that's good. Now negative 3/4, it already has a common denominator of 4 there, so we'll just put the plus negative 3/4 there. So when we add these two numbers, we're going to end up with a negative 5/4. Now a lot of students in algebra want to change that to a mixed number, negative 1 1/4, but you don't have to here. As long as these numbers are reduced, just leave it alone. They'll leave that improper fraction in algebra. Decimals, you ask? Yes, we have examples for you. So again, the signs are the same, 4.3 plus negative 0.058, negative 4.3 here. So when you add decimals, what's the rule? Well, of course, you line up the decimals. It's almost like in your checkbook. So we'll make that 4.300, 0.058. So we'll go ahead and line up those decimals and add the two numbers. That'll give us 4.358. What kind of 4.358? Well, when we add two negatives, we are finding we get a negative. We take some money out of the bank and some more money out of the bank. That's how much we've taken out. We lose this much in a poker game and this much. Well, it'll be hard to lose that much money. I wish I could lose that much money in a poker game, but that's how much we would lose. All right. So, are the signs always going to be the same? No, it's not always going to be that easy, just adding the numbers and putting the signs. Of course, the numbers will also be different. So let's look at a graphic to illustrate that. Okay, when the signs are different, you're going to subtract the larger number from the smaller number and put the sign of the larger number in your answer. Or I'm sorry, I think I said that wrong. Subtract the smaller number from the larger number, excuse me. All right, so let's go to some examples here on that. So when the signs are different here, and again I've illustrated it just so I can keep it straight myself, subtract the smaller number from the larger number and then put the sign of the larger number in your answer. So we start with negative 40 plus 32. Now what a lot of students don't understand here is you're subtracting the 32 from the 40, the smaller number from the larger number. So 40 subtract 32 gives us 8. What kind of 8? The sign of the larger number is negative. Okay, so different signs, subtract smaller from larger, put the sign of the larger number in your answer. Okay, another illustration, 16 plus negative 40. Different signs, subtract. Now what are we subtracting from what here? Well, we're subtracting the smaller number, 16, from the larger number, 40. Okay, and we're going to borrow here, and that's going to give us a total of 24. What kind of 24? Right, negative, sign of the larger number. And I know it wouldn't just be right without also doing fractions here. I know you love these. So again, even when you add positive and negative fractions, you need that, yes, common denominator. So the common denominator here will be 7 times 5 is 35. And we want to go ahead and change 1/5 into 35ths, and to do that we're going to multiply top and bottom of this fraction to make equivalent fractions by 7, and that'll give us 7 over 35. Okay. Then on negative 3/7 you want to change that to 35ths by multiplying top and bottom by 5, and that will give you a negative 15 over 35. So you really can't use your same signs and different signs rule with fractions until you get a commonality, a common denominator. And now I think you can see it a little better here. Different signs, it still works this rule up here. Subtract the smaller from the larger. 7/35 from 15/35. So we would take that smaller fraction, subtract it from the larger one, and that would leave us with what? 8/35. What kind of 8/35? Yes, negative. So again, a good illustration here. Continuing, negative 48 plus 70. Again, different signs, and you can tell they're different. The visible signs directly in front of the number will give it away. Subtract 70 from 48. We're going to have to borrow here again. And that gives us a 22. What kind of 22? In this case, positive. Now, in algebra, they usually don't write the plus sign for positive numbers in front. They'll just leave it plain old 22. And an example of this with decimals, again, different signs. Now, boy, this one really blows away students in some of my classes. Subtract the numbers, the smaller number from the larger number. Now, which one's smaller and larger here? Well, the decimal is smaller than the whole number. So again, we'll have to line up our decimals. 1.00, subtract 0.58, and when we borrow, we end up with a 0.42. What kind of 0.42? Well, the sign of the larger number in this case is a negative. So negative 0.42 or negative 0.42 would be the answer there. Okay. So, as we are talking about these signs, the signs are one of the most important concepts in algebra that I see students always have trouble with. I mean, once your signs are solid, you will feel the power. You will be empowering the algebra like the title of this series says, and that's what we're after. So let's continue with some more examples here. We'll go back down, and notice I've got this one, empowering your signs. All right, so now we're really going to try to mix things up and see if we can confuse you. Hopefully not. Now, when you add a whole string of signs like this together, what I tell students to do is you can bring some color into this. Go ahead and underline all the negative numbers in red. All right, and then we can use our same sign rules here. So we want to get all of our eggs in one basket. So when we add the negative numbers, same signs add, put the sign, we're going to end up with 18 plus 10 is 28. Plus 4 is a negative 32. Adding all the positive numbers up, we can go ahead and do that in green. All right, and 12 plus 9 is going to give us what? A positive 21. So using our same signs rules, we went ahead, we got all the negatives in red here. We end up with a negative 32. We get all of our positive numbers in green. We add up with a positive 21. Now, where does that leave us? Well, now these signs are different. What's the rule? Subtract the smaller number from the larger number. So we're going to subtract 21 from 32, and we're going to get, well, we're not going to get that. We're going to get 11. And what kind of 11? Sign of the larger number is negative. By the way, I call this the student brain fart. That's how the only way you can miss these is add or subtract incorrectly, so don't feel bad. Even we do it at times. Usually I have students to catch me on the board when I do something like that, and of course I'll say something to the effect of, well, I did that on purpose. You know, so just seeing if you guys were paying attention. All right, now let's go ahead and try a whole bunch of fractions here, different positive and negative signs to throw you in the rough here. So what is the common denominator of 6, 4, and 9 here? 6, 4, and 9. How about we try 36? I think 36 would be the least common denominator of those. So we want to go ahead and change these unlike denominators to like denominators. So negative 1/6 to become 36, we would multiply top and bottom by 6, and that would give us a negative 6/36. 1/4, we would multiply top and bottom by 9, 9 over 36, and negative 1/9 by 4, and that would give us a negative 4 over 36. So now we can compare apples with apples here. We have a common denominator. Now, let's think about this. Which ones would you guys add together first out there in the audience? I would add together the two negative numbers, same signs here. I would take the negative 6 over 36 and the negative 4 over 36 and put those together, which would give me a negative 10 over 36. Same signs, add, put the sign. Okay. Then I would go ahead and bring the plus 9 over 36. There are no other positive fractions here. So again, now we can look at our same signs or different signs rule. Different signs, subtract. 936 from 1036 is a 136. What kind of 136? Right, negative. Right, so hopefully we're starting to get a good feel for these signs now. And the last example here, again, I'm trying to get a string here. So at any time during our series, you guys can always stop this at home and try one and see how you do. You can freeze me. You can unfreeze me. You know, I've had worse things happen to me, you know, as a math instructor for 15, 20 years here. So go ahead and let's look at this one. So I would go ahead and get all my negatives in one basket first. All right, and it's easy to tell which ones are negatives because they have the nice negative sign there. So 20 plus 14 is 34. Plus 3 is a negative 37. So all of my negatives total 37 here. My positives, 22 plus 8 is 30, plus 9 is a positive 39. So the final answer will be subtracting the smaller number from the larger number, putting the sign of the larger number a positive 2. All right, so how did you do on that one? I don't know if you froze me or not, but hopefully you're following along and taking the good notes and writing these examples, and once you're done, you will go and practice and execute and become real good yourself outside of the tape here. All right, let's go to the next graphic. The next graphic we want to talk about is the double negative property. All right, these signs, it's just going to be a lot of fun today. Now, the double negative property reads the opposite of a number is the number itself. All right, now how confusing is that? The opposite of a number is the number itself. All right, so let's look at an example here, going back. And I've got the double negative property written out here. So let's see if we can make sense of this. I mean, a lot of students look at this in a textbook and they say, what does that mean, Young? So I'm going to take the number 7. It's a lucky number. And then I'm going to ask you, the audience, what would you say the opposite of 7 would be? And most people would say negative 7. And I would say that's exactly right. So here's how you write it. The opposite of 7 is negative 7. Right? Every number has an opposite, by the way, except one. Do you know what that is? Yeah, 0. Poor 0. He's neither positive nor negative there. So anyway, now what if I kept going with this idea and I said, what is the opposite of negative 7? You all would say, well, that's positive 7, Young. That's not a problem. But here's how a lot of books will write that. The opposite of a negative is a positive. The opposite of a negative. So you can actually write that out. That's what that means in this context. The opposite of something negative is something positive. Does that make sense? I think so. And even if we started out with a negative number, let's take negative 8 for example. And I said, what's the opposite of that? Well, you would say it is positive 8, right? I mean, so there's the opposite of negative 8, and it comes out a positive 8. Now, how far could we go with this? We could go on forever. We could say, I'll give you the number 10. Its opposite, negative 10. The opposite of negative 10, back to positive 10. So whenever you have a double negative, I want you to change that into addition, all right? And then we could say the opposite of a negative 10, and we could just keep doing that back and forth for eons and eons. All right? So that's a little bit of the double negative property. And let's look at the next graphic now. The definition of subtraction. The definition of subtraction says a plus a minus b, and notice they're separating the negative number with the addition sign, and a plus a minus b is the same thing as a subtract b. So remember that 7 minus 20 can be written as 7 plus negative 20. And negative 23 minus a negative 50 can be written as negative 23 plus 50. So notice right in here, I'm bringing my hand up here, that when you see that double negative here, that we're going to change it to a positive right there. The visual sign directly in front of the number will always give it away. All right. So let's go to some examples with that. The definition of subtraction. So you might, in the first series, or the first thing we talked about earlier, saw 7 plus negative 8. Another way to write that is 7 minus 8. Now, if you were putting these together, would you say same signs are different? Well, I would say the signs are definitely different. That's a positive 7 and a negative 8. I want you to also recognize the subtraction symbol means the same thing as this. These are interchangeable. So different signs subtract the smaller number from the larger number, get 1, 7 from 8. What kind of 1 in either case? Negative. Right? Or you might get something like this. Negative 10 plus negative 6 can also be written as negative 10 subtract 6 by this definition of subtraction. Same signs are different. No matter if it's addition or subtraction, I want you to recognize this. They are the same. You will add the two numbers, put that sign in your answer, negative 16. Or this is the worst case scenario right here, folks. If you said negative 5 minus a negative 8. Now look at all of those negative signs. Oh my gracious, that scares some people sometimes, but don't let it scare you. Simply take, whenever you see this double negative here, and change it to addition. As that one graphic stated, negative 5 plus 8 comes out to give you different signs here. So subtract the numbers. What kind of 3? You guessed it, positive, positive. So that is the key thing here with that double negative property and the definition of subtraction. The only thing I ever want you to change is a double negative. All right, let's look at some more examples here. I have got a ton of mixed practice here. I want to get you guys tough on your signs. So here we go. Let's rock and roll. Are you ready? Okay, negative 12 subtracts 15. Same signs or different? Same. Add the two numbers. Put the sign, negative 27. Negative 5 subtract negative 12. What's wrong with this picture? Yeah, that double negative here, whenever you see that minus a negative sign, you can do this at home. Change it. That's the opposite of something negative is a positive, addition. Different signs subtract. 7. What kind of 7? Positive. Okay. Some decimals. 2 subtract a negative 3.04. Again, that double negative here, let's not even look at that anymore. Let's change it to its true sign. It's 2 plus 3.04. And if I went ahead and put a decimal after the 2 here and lined it up, that would give us a total of 5.04, positive. Negative 27 plus 30, different sign, subtract, 3. 9 minus 40, same signs are different, subtract. What kind of 31? Negative. Negative 14 plus 8, different sign, subtract. 6, what kind of 6? Negative. Sometimes students will waver on this. Half my room will say positive, half my room will say negative, and I'll say, are you positive it's negative? And they'll say, yes, Mr. Young, we're positive it's negative. And in this case, they would be right. Negative 6.3 minus 2.04, same signs, add the 2 numbers, so we'll go ahead and line up those decimals. 8.34, what kind of 8.34? Put the sign of those numbers in your answer, negative 8.34. Okay. Negative 1/2 plus 2/7, need a common denominator here, which will be 14, multiplying the 2 denominators. Negative 1/2 becomes a negative 7/14. 2/7 multiplying top and bottom by 2 becomes 4/14. And that gives us a total of, different signs, subtract, 3/14. What kind of 3/14? Negative. All right, so I hope you're getting a feel for these. Double negatives here. Change that into addition. Negative 8 plus 4. Different sign, subtract, negative 4. And I like the old 0 thrown in here. Now, if you have a number and 0 plus or minus, and we're going to talk about this later in properties, does not matter. It's just going to come out to be that number. So negative 12 subtract 0 would still give me a negative 12. Okay, so we're going to see how you're doing here. So how are we doing on these signs? If you can get these signs right, adding, subtracting, you're going to be awesome here. So I'm going to go ahead and wrap it up with 2 final examples here, and these are going to bring it home for you. So I want you to go ahead and look at these here. And again, you can freeze me if you want. If you can do these, you're in great shape on adding and subtracting. What's wrong with this picture on this string here? All these different signs, wherever I see these double negatives, I would not even write that out like that. So I'm going to change this into negative 12 plus 3 plus 4 plus negative 6 minus 9. So notice I'm not changing anything except those double negatives. Plus 8 plus 16. So go ahead, line up your negatives, same signs add, and you can tell they're negatives because the sign directly in front of them gives it away. Whether it's a subtraction or minus sign, you get negative 18 and 9 is a negative 27. The positives total here, 11 and 4 is 15 and 16 is plus 31. And you get a final answer of 4. Try this one and see how you do on your own. Okay, and see if you can get that. In closing, now that you have the algebra concepts within your grasp, your job is clear. Like a weightlifter, pumping iron builds muscle. A weightlifter who slacks off and does not put in the time lifting may get flabby. In math, lots of practice builds strong understanding in test grades. No practice, and when you get your test back flabby, may be replaced with shabby. Think about it, take care, and we'll see you next time.